Welcome to this book, and in this video, I'm talking about the first chapter. It's about introduction. So, at first, I want to talk about what is statistical learning. So, generally, we can categorize statistical learning into two parts: supervised and unsupervised. They're both about how to understand data. And now we need to distinguish what is supervised and what is unsupervised. They are distinguished by if we have a Y, which is in machine learning we take it as like label, like we have some features, and if we want to predict something, and if we have a label, it means it's supervised learning. So here, supervised means that we have some kind of symbols or information to supervise the learning process. But in another case, we do not have a label. Like we have some features or some people, and we want to just categorize them, like cluster them. This means unsupervised. So the distinguish of supervised learning and unsupervised learning depends on whether we have a label. If we learn from the label, this is supervised learning, and if we learn without label, then it's unsupervised learning. And in the following, I will give some examples, then this concept will be more clear. Okay. And under supervised learning, we have two typical cases, which is regression and classification. Regression is use some data to predict a value, a continuous value, like we predict the price of the house and price of the stock market and the price of the maybe and people's wages. So they are all about a continuous value. And categorical it's very simple. It's like we have a data sample and we want to categorize if it's class A, class B, or some other cases. A typical case would be like binary classification, where we have some samples and we want to categorize if it's up or down, or if it's good or not, if it's positive or negative, something like that. It's all categorical. So in the following, the author gives 3 examples, and the first two is about supervised learning, and the first one is continuous, and the second one is categorical. And for the last one, they also talk about unsupervised learning. So there are generally 3 typical cases. Okay, then we are going to go through the 3 examples. The first one is called wage predicting. We are given 3 variables. We are given like when we are talking about data, we have like usually we have the x it's a 2-dimension, right? And it's like a table, and for each column we have a name for this column. Like in this example, we have age, education, and wage, and each row is a data sample. In this case, each row is also a person, and in some other cases, it can be maybe a house or stock or some other information. And the columns are some variables, the name of variables, like it can be age, education, wage, and it can be some other cases. This is data. What we are talking about data, they are always organized in this way. It's a 2-dimension like a matrix. And in this example, what we are trying to do is to predict the wage based on age and education. We know that there is some relationship between age and education. Okay, and we can see that it can be plotted in this way. Like, y x is always wage, and we have age, year, and education level. Yeah, and we can focus on maybe the first page as an example. So each data point means a person. And we can see that it's we can see some trend, right? Because we can see that when the age go up, the salary generally rise and go down as people get older and older. This is a relationship between age and wage, but we can see the relationship is not clear because the point is too scattered. If we fix like we found people who are age 14, and we can see that its wage varies a lot, very a lot. And the same thing happens to education level. Here, numbers maybe mean some categorical values like maybe one means kindergarten, and two means primary school, and five means PhD. And it's my guess. And we can see that as the education level raises, the mean value of the wage also rise. It's positive. We call it a positive relationship, and that's the way how we like visualize the data. And here, the line means that we're trying to predict the wage with age itself, and we can find that it's not enough because people with the same age can have different education levels, so we found that they scattered a lot. Also, we can call it a large variance, so it does not help us a lot to predict one person's wage. But we can include more variables if we consider the most accurate prediction of a given man's wage will be obtained by combining his age, education, and the year. Here, the year means that in which year is salary. So as the years goes, maybe the column maker will change, so salary may raise. So we need to make prediction based on three terms. If we ask a human to try to predict in this way. So it's the same for the data science. We need to combine all three items to make an accurate prediction of one person's wage. So the question is like, how can we do that? How to do it, and how to build a model, how to find the function to make prediction, and how to estimate values. And this is what this book is about to talking about. And the second one is, let's move into another example. It's categorical. Okay. So it's also about like marketing. Sorry, not marketing. That one is about wage, and this one is about marketing. We are trying to, we are given, as the same as this example, we are given some information, and we are required to predict some information. And here, the information we are given is the change of yesterday's price and the change of 2 days previous price and 3 days previous price. So we have this as the information we have, and we are trying to predict today's direction. So it's kind of like you are trying to buy stock, and you can see the previous trend, and you want to buy that in this year. So you are trying to predict where it will go up or down. So this is categorical problem. So here we need to mention that it was mentioned that whether this problem is categorical or regression, it only depends on what the y is. It's not decided by the x. X can be mixed. It can be categorical. It can be some continuous values, and it can be mixed. But what's really important is that the type of y, because it will affect which kind of models we are going to use. And usually our models would handle different x at the same time, so it does not affect the methods we are going to use. Sometimes it will affect some details of the design of the model, but in general, it won't affect the selection of our model. So here is a categorical problem. We are using some input information X to predict the category of the Y of this item of this data sample. So here we can say that if we plot the distribution, we will find that no matter today's up or down, the distribution of yesterday's price is generally the same, very similar. So this tells us that the trend of today go up or down is not very related to previous days. So this is reasonable if they are highly related. It would be like stock marketing is too simple, right? People can make money by it. So it's reasonable that we say that it's hard to distinguish whether it's going to up or down based on the previous days statistical. But in chapter 4, it also shows that we can predict the like in 16% of the time. So it's not always successful, but it's better than just random guessing. So this is about categorical example. And the third one, and this is also the last one, is about unsupervised learning. Unsupervised learning may be hard for people to understand at the beginning, and it's about to do something without label. So compared to previous examples, we do not have X. We do not have Y, which is the value we are going to predict. Instead, we just have a bunch of data. And there is an example like what we are going to do. I'll also give an example of a gene. And like for people's gene, they have some features, a lot of features, and we can express them by maybe
V1,
X1, X2, X3, and that's a lot of like maybe 64 cancer cell lines. So So this is the number of X for each data sample, and we would find that it's a very big number. So and what we are going to do here is to just use these features to categorize them. So what we can do is we can use some techniques to work out. This is not learned already. It's something we are going to talk about later. It's principal components. And use these techniques, we can decompose, to dimension reduction. We can reduce them to 2 dimensions, and then we can plot them in one figure. And we can see that they will be 4 groups. Using these techniques, we just put all the samples and we can say that they are separated. This is interesting because if they are separated, we may assign different categories for them. Right? We can, although we do not have labels before, but we can say that when we plot these points, we found that they are separated. So it means that they may, it's possible that they have different categories, and it's simple to do it if this is only 2 dimension, because we can visualize them and it can be read by human. But when it comes to a very large dimension, we need to find a way to do dimension reduction. And this is also part of the unsupervised learning. Like how can we deduct the dimension from a very large to a small number and visualize them, and also how we can categorize them. Because here we can categorize them when we see this figure, because they are we can see that it's 4 groups, right? But how to do it mathematically? How to build an algorithm to assign different categories for a bunch of data, it looks there are two styles. There are two groups. That how can we use code or math to categorize them is still a problem. So that's all how that's an example of unsupervised learning. So generally it's about like we have a bunch of data, but we only have features and we want to do something. Okay, and also the author also shows that the category of these features. So it's not a category of these features. It's just a kind of pattern. Like we have the gene and also collect information like whether this gene affect people who person who have this gene have some certain kind of maybe diseases, and we can label this each person with different color to indicate the disease they are related to, and we can find that generally and this group is aligned with this group, and this green one aligns with this one, and the red one cannot align with this one. So it means that when we use low label, we can categorize the data samples in some degree, and it may have some relationship with the true labels or some kind of feature, some kind of like response we have. So that's the meaning of that's the why we need the supervised learning, unsupervised learning. Yeah. So this unsupervised categorization may help us to build some connections with some future analysis. Yeah. And this is about what is statistical learning. So we can have a quick go through. We can have a quick review. So it can be categorized into two parts: supervised learning and unsupervised learning. So supervised learning include regression and categorization. And there also gives three examples. First one is use age and education to predict wage, which is prediction. And the second one is use previous days change or price to predict if today is up or down. And last one is about gene. It talk about when we have gene of a lot of features, but we do not have the response value, and we can do dimension reduction and visualize them and categorize them, and found that we have some relationship with the value we are going to investigate.